Hello everyone and welcome to my final presentation for VITS 2333 Network Analysis Design. Today, our team from section S3G2 will be presenting our comprehensive network infrastructure design for Melaka ICT Holdings Sdn Bhd, also known as MITCH. We would also like to thank you our lecturer, TS Dr. Nur Azhar Bahaman for his guidance on this project. Let's start with a brief overview of the company. MITCH is a key government-linked company responsible for ICT and AI development in Melaka. For our network design, the most important factor is their workforce structure. They operate across two locations. Their main headquarters is Ayer Grove, which supports 70 users, and separate branch office with 90 users. Our goal is to design a network infrastructure that seamlessly connect their various departments like HR, Finance, and IT across both of their sites.
Next, let's talk about why we are doing this project, what we want to achieve, and exactly where this network upgrade will take place. To give you some context, Melaka ICT Holding is currently facing a few big network issues during peak office hours. Employees experience bad network slowdowns and drop out because the current setup can't handle the traffic. On top of that, there is a lack of security separation between departments, meaning sensitive financial files share the same space as everyone's office traffic. There are also Wi-Fi dead zone in key meeting rooms, and if one main switch fails, the entire office loses connection. With this problem in mind, we have set 3 core objectives for this project. First, we want to redesign the network from the ground up so it's completely secure, reliable, and easy to expand. Second, we introduce modern security and performance upgrades. And third, we are making sure this is a highly cost effective. We have carefully planned everything to stay strictly within our target budget of RM500,000. Now, where is this actually happening? The scope of this project covers a full network overhaul across 2 primary locations. First, the headquarters, located at level 10 Menara ITC, which needs support 66 users and devices. Second, the newly established branch office, which will support 19 users and devices. By upgrading both sites, we will create one unified, fast and secure network for the entire company.
For the technology evaluation, we selected Gigabit Ethernet as our primary LAN technology. Evaluated again key criteria like reliability, capacity and cost. On the other hand, RIP was rejected due to its 50 hop limit and slow convergence. Our network capacity scaled up to 1 Gbps for backbone 1, maintaining a high reliability rate of 99.98% to 99.99%. Moving on interconnection mechanism, we are implementing a star topology with the server room acting as a core hub. This follows a 3-tier hierarchy where the core layer utilize a MikroTik CRS 328 layer 3 switch for intervilla routing. To ensure high availability, we have integrated a dual link LAG redundancy between key switches, and a secure branch connectivity is established using a single IPsec1 tunnel over TM Unify.
Logical design. First, for network management, our design use a centralized network management system or NMS. The NMS is placed at the HQ server room because the server room is the main control point of the network. The approach used is hand management where administration can monitor to device to and also the existing network connection. The protocol use are SNMP, ICMP and NetFlow. This protocol help the administration monitor device status when the users log and traffic flow. For remote access, we use SSH instead of Telnet because SSH is more secure than Telnet. The software proposed is PRTG or Nagios SI, and it monitor around 75 hosts across all HQ department. Secure remote SSH is also provide over the one management tunnel. There are 3 security for our design: firewall, DPI, and also level 2 security. Okay, that's all. Team follow a centralized distribution layout. Based on the floor plan, all departments connect to the server room as the main point. For cabling, single mode fiber optic is used for backbone link between core and also the distribution device. It supports 1 Gbps and above and remove distance limitation. Compared to copper, Cat6 UTP copper cable is used for horizontal cabling to endpoint device because it support to 10 Gbps. And it also provides stable gigabyte level performance. I think that's all from me. Thank you.
70 CIDR 28 for meeting room and guest. VLAN 80 is 192, 168 and CIDR 25 for branch office. So for the routing strategy is using CIDR 21 logically subnet for HQ and branch. Internal routing is IGP on MikroTik L3 core switch, OSF benefit VLSM, fast convergence cost-based bus selection. External routing EGP between 40 firewall and TM Wi-Fi. BGP benefit classless ada 21 block, reliable public facing service. InterVLAN L3 hardware routing on core switch, branch tunnel OSPF over IPsec VPN, branch SSHU DB seamlessly, not used to RIP, limited to 15 hopes, low coverage, target delay reduced from 100 ms to 40 ms. So the below is the diagram. So that's all. Thank you.
So I will present about the current and future logical design. This is the before and after network architecture configuration. So this is the current. The flat layer 2 topology has no VLAN segmentation, only basic firewall. There's no DPI or web filtering, and they're still using legacy 1 GIPS copper uplink to core bottleneck. They're still using the standalone APs without the VLC, causes a poor roaming, single path ISP link, causes no redundancy, no centralized network monitoring system, causes a manual fault detection, and Wi-Fi 6 without enterprise grade security causes the WPA3 absent. And there is also no QoS or traffic treated equally. And this is our team have proposed a new future upgrade for them, which is 3-tier hierarchy, core switch, distribution switch, and access switch. And we also apply a new firewall, Fortinet FortiGate 60F firewall with DPI and Coswave. We also be using single mode fiber backbone 1 gig per second for crawling and 14 MikroTik CAP SLAP with centralized management, dual link LAG redundancy between key HQ switches, PRTG or NAGIL centralized network system with SNAP or syslog, WPA3 encryption across all wireless access points. And we also apply 8 billion for full departmental and server segmentation. Thank you.
Moving on to the physical design, we are making a major upgrade to the hardware. First, we are replacing all copper cable with single mode fiber for the backbone. This will remove speed, bottleneck, and improve reliability. Second, we are moving away from scattered equipment. Everything will now be organized in 42U server rack with structured overhead cabling. Third, we are introducing MikroTik L3 core switch and a dedicated server switch to isolate internal system. Lastly, we add heat vision biometric terminal to modernize staff attendant. This whole transition is planned for a 7-week rollout to ensure minimal disruption to the office. For conclusion, to weigh out our proposed network solution successfully achieve all project goals. First, scalability. Our tire design can now support over 84 users and is ready for future IoT growth. Next, security. We implemented layer defense using FortiGate firewall, VLAN segmentation, and WPA3 encryption for wireless. Performance. By using OSPF and layer 3 hardware routing, we expect to reduce network latency to less than 40 ms. Next, budget. Most importantly, this entire enterprise grade solution fit within the 450k to 500k ringgit budget. However, this design provides Melaka ICT Holding with a network that is reliable, secure, and cost-effective, meeting all UTeM FTMK standards. That's all from our group. Thank you.